Okay.
But what I'm asking is that only from this cycle decomposition. So this thing, what we are looking at is the disjoint cycle decomposition. From here,
Okay.
also you can say whether something is in AN or in SN. Okay, this is something which you can think about later. Okay, this is very simple. Okay, but I
Okay.
think this is not what you were trying to say. I think so this is of course cycle structure, but yeah.
You said if two element in AN or
Hmm.
SN conjugate, are they, yeah, in AN
Mm-hmm. So
or SN, yeah.
right. So if they are SN conjugate,
Uh, you're asking if whether they are AN conjugate or not.
yes, right, right.
Uh, that is not true.
So if you say that is not true, then can you give a counter
Okay.
example?
Yeah. If we take S3,
Uh,
S3,
right.
you can take yeah. Uh, yeah, if in this all three cycles are conjugate, like cycles of length three or conjugate. Uh, A3, yeah, of length three or conjugate.
Right.
In A3, there will be identity 1, 2, 3 and 1, 3, 2.
Yes. All the cycles will be in A3 also. All the three cycles.
Yeah, yes, but 1, 2, 3 and 1, 3, 2, or like we cannot find any um like odd like even number of transposition, so that if we do conjugation we cannot get 1, 2, 3 and 3, 2
Ah,
back.
okay, let's see. I mean, I suppose it is correct, but let's see for ourselves.
Yes.
So obviously there are only 6 things to check, but no, there are only 3 things
No,
to check.
only three.
Haha, right, right, yeah.
Yeah,
So what are those 3 things? Identity,
yeah. The 1, 2, 3 and 1, 3, 2.
exactly. And uh,
No, we,
yeah, and it will obviously not work.
yes, yes.
Hmm. Yeah, this none of them. Okay, yeah, correct, correct, correct. Okay.
Like like we doesn't know like if they have same cycle length, they are conjugate like that, we
Yeah,
doesn't
that
know
also
in
we
A
don't
and
know.
no.
Exactly, exactly. That's right.
Yeah,
Yeah. That, I mean, if that was true, then of course, then this result would be true.
yes, yes.
Yeah. Yes. Yeah. I think this is a nice
Also
example. Yes, please.
yeah, also like in AN uh,
Hmm.
like all, like you said, all like all uh, if it contains three cycles,
Hmm.
and if it contains three cycle, then like it's simple, like you are trying to show that, no.
Yes. Yeah, we were trying to show that
uh,
AN is simple,
yeah,
and for that we said that if wait 1 second. So Arnab, is this previous counter example clear to you? Do you understand this?
Yes, yes.
Yeah, this can be an important sort of because it has a small counter example, so I think it's nice. Yeah, but then yeah, now let's see. So this we sort of proved, but then here is the thing that if H, so if sigma in H is a 3 cycle, then what is the question?
Okay, like we can show like all three cycles are conjugating AN, but how like produce like if we how to show like it contains three cycle,
All three
like we
cycles.
were trying to show. Yes,
All three
yes,
cycles. Yes, yeah. Okay, okay.
yes,
So you are probably thinking that, yeah, if all three cycles are not conjugates, then how does it contain all three cycles? Yeah, it can still contain, because it's a subgroup, it's not just a conjugacy class, right? So
okay, okay,
yeah, it can still contain. So if sigma in H is a three cycle, uh, and H is normal in AN, right? Then H contains all three cycles. All three cycles. Okay. And of course, for this, I suppose I assumed that n is bigger than or equal to 5.
okay,
Okay. So yeah, so the extra space that is given by the two variables can help us. I don't know how to prove this, but let's think about this. Let's prove this quickly, then we will move to the questions. But yes, this was one of the parts of our proof, which we did. This part we did
yes,
not do.
yeah,
Hmm. So let's just assume that the sigma is 1, 2, 3. Yeah, so I just to come back here just for a second. I was saying that something is conjugate here, then it is conjugate there. And I had a different intuition, so I was a different reason I was saying. But yeah, obviously that is not correct, so I'll not get into it. So later, if I can say. But obviously it turned out to be wrong. But yeah, okay. Yeah, so now we have this. So then you would like to say that, okay, if mm, maybe, yeah, maybe sigma 1, if this is I1, I2, I3.
yes. Okay, like I was trying to show this, like in SN, we know that the sigma and sigma 1 are conjugate. So, uh,
Hmm.
yes, okay,
Yeah,
uh, like if, okay, I was trying to find that, like if gamma is some element, if we conjugate with 1, 2, 3, we will be getting back like gamma, yeah,
right,
sigma, gamma inverse should be
right,
equal to I1, I2. Yes, I1, I2, I3.
correct. And I'll just write 1, 2, 3.
Yeah, yes. Yeah. Like right side, it will be like if you want, it is nothing but gamma of 1, gamma of 2, gamma of 3 equal to.
Yeah, correct. Yeah, that is again repeatedly we are using that lemma, which
Yes, yes.
observation.
Yeah, yeah. It should be equal to I1, I2, I3. So we can take gamma to be 1 I1 transpositions. Gamma is 1 I1,
Uh,
yes. 2 I2,
mm, but there can be
and
problem if you do this. Okay, anyways, 3I3.
yeah, yes, yeah. Like we need like if we take like another transposition, like so like if we produce another transposition so that yeah doesn't affect yeah I1 and I2.
Yeah, some I4 and
We
I5.
can
Or yeah, so if you want to take, okay, see, if you take I4 and I5, then it certainly works.
Yes.
But of course, then this I4 and I5 should be different from all this.
Yes.
Okay.
Yes. Yes.
So if n is bigger
Yeah.
than equal to 7, then it's no problem, or bigger than equal to 8, then it's no problem. But otherwise, see,
Okay.
otherwise there's some small casework which you have to do, right?
Okay.
It's some small casework, right? I mean, so you just have to do it. That's not going to be difficult, right? Yeah.
Yeah.
So what I'm
Yeah.
saying is that if n is bigger than equal to 5, you can surely find such I1, I2. You can surely put another transposition here so that everything is still fine. Okay.
Yes. Okay.
No, but let's do it. Okay, so let's do it. Yeah, so for example, I will say like case 1 is that I1, I2,
You can take this as I1, I2 itself. It will
okay.
work.
Oh, all
I1,
right.
I2.
Let's see. So you take I1, I2,
So,
then, but what if
yeah.
I1 is equal to 1? Oh, sorry, it cannot be. What if I1 is equal to 2? If I1,
That will, mm,
then it's not good, right? Then 2 goes to 2. Okay. So then you have to change. I mean, so that's
okay.
why you have to do, I think you have to do some small case work, right? You see?
Okay.
Yeah. For example, like as like what you are saying, like that will work if
Okay.
yes. So if these two sets are disjoint, correct? If these two sets are disjoint, then I can take I1, I2, but I would rather take maybe no. So yeah, let's think. So can we just say for this case, what so the whole goal here is to take one more transposition so that it's still,
Yes.
yes.
Yeah, they are conjugating AN.
Exactly. Basically, we have to take one more transposition so that this still holds. 1, 2, and 3 still, yeah, correct. So
Yes.
basically, yeah, you can just take this. In case 1, right? Because just check, 1 goes to I1, but I1 is not 1 or 2, so 1 goes finally to I1, right? This permutation will send 1 to I1, right? Or let me write properly. Let me write properly. If case 1, if this is phi, okay, then you take this, right? This also sends 1 to I1, 2 to I2, 3 to I3, right? It works. Means what I am saying is take this to be your gamma, right?
Okay.
Right? And this was the easy case. So if
Yeah, it will work.
it will work, right? So what will it be if the intersection is, let's say, or I mean, right? So if I take if I say that I1 is equal to 2 and
Yes.
and let's say that I2 and I3 are disjoint. So of course, then I2, I3 cannot be 2, right? But what if they are, and let's say they are disjoint with 1. So what should we take in this case? Arnab, can you tell? Means this, see, what can we do in this case? So I1 is 2. So okay, just write here, no, just write here. I1 is 2. So now what extra transposition should I attach to this?
Uh-huh. Yeah.
नहीं समझ आ रहा शुभम का।
हाँ, so what are you not understanding?
लाइक हम निकाल क्या रहे हैं, केस 1 केस 2 करके
Yes,
समझने की कोशिश कर रहा हूँ।
yes. So okay, so I'll just tell you. Yeah. So see, as you understand that what we are trying to do is we are given this gamma. So we are trying to show that H contains all three cycles, right? We want to show that H contains all the three.
लाइक गामा 1 गामा 2 गामा 3 इक्वल टू I1 I2 I3 तक समझ गया, उसके बाद
Okay, right. So you want a gamma such that gamma 1 is I1 and so on. But we want gamma in AN. Okay, so gamma should be even number of transpositions, right?
यस
But if you write this condition only, then you get the simplest permutation possible is this. But this is not even.
Yes.
Right, Arnav?
यस यस
So that's why we want to take one more transposition somehow and attach to this so that still the same condition is satisfied. And that is why you see in case 1, I have attached 1, 2. This permutation, if you see, this is even permutation. It does the job. Okay. Now we want to look at the other cases.
You can take I1, I2 also. Like it doesn't affect anything. Like
Okay, so
gamma 2.
what should gamma be?
Okay. I1.
Leftmost?
Yes.
Okay.
1 I1, 2 I2, and 3 I3. I1, I2.
Yes. Okay, let's see.
Yes.
So if 1 comes in, then 1 goes to I1. Okay.
Yes.
Now when 2 comes in, then 2 is I1. So 2 will go to I2 because I1 is 2 in this case. I2 and I2 is
Okay.
again, right? So yeah, but I think it works, right? Or does it not? Let's see. No. So this I1 is equal to 2, remember? That's for, yeah. So now 2 goes to I2 goes to 2, but the 2 goes to 1. So 2 goes to 1 in this case, and that is not good, right? Because these are no more disjoint transposition. I mean, you can understand all that, right? These are no more, so it's more complicated because the transpositions are not disjoint. Okay, yeah. So, okay, let me erase this for the time being. Let's think. Okay, so what I can say first thing, which will make sure we don't have to do other cases, is this. We are assuming n is bigger than or equal to 5, right? Right?
Yes.
So, oh, no, sorry, nothing. Nothing. Yeah, let's try to do this. Basically, we have to use the other variables, just in case. Yeah. This is just partially I've written. So you see, I can attach, I think this is what maybe similar to what Vaishnavi was saying, but if I attach to the left, then I think it's correct. So now if you bring in, then, oh, wait. Sorry. Nothing. Yeah, this works. So now you can check. 1 goes to 2, which is I2. And then there is no 2 again after that, means to the left. We are composing from the right. Now, if you take 2, then 2 goes to I2, right? Yeah, 2 goes to I2. So I should not be writing. Sorry, it's not. How did I write this? 2 goes to I2. Yeah, 2 goes to I2. And 3 comes, 3 goes to I3. Yeah, this works. Yes. Yes. Yeah, this works. Yeah, does it not work? Hello? Hello?
Hello.
Haha. Yes. So it works, right?
No, one doesn't go for I1.
No, why not? 1 goes to 2 and 2 is I1.
Okay.
Yeah, correct, right? Yeah. Arnab, it's correct, right? Please tell us. Yes. Sure. So similarly, you should,
Okay.
similarly, you can do the other cases. Okay. Yeah. So you see, I mean, so far we did not need to introduce any new variable because already in this, the 5 variables are being used. Okay. Right. So if n is equal to 5, then this proof is sort of tight. You cannot improve in this, in some sense. Yeah. Anyway, let's move forward. Yeah. So yeah, before we take the problems from Arnab to try, so this was just a small piece. Yeah. So basically, what we have proved is something slightly stronger. What we have proved is um, the okay. So that is the thing, right? 1 minute. 1 minute. Yeah, so we have proved that all 3 cycles are conjugates if n is bigger than or equal to 5.
Yes.
Yeah, obviously, I mean, the example that you gave was for S3, so that's why maybe. But yeah, so you see, this was thought of my, yeah. So we have proved more than, so let me just speak on that a little bit. Just a little bit, yeah. So suppose, now this is just a general group theory I'm saying, okay, that there is a small difference, there is a difference, you just see. Suppose that n is a normal subgroup, okay, like right? So if you take an element, okay. Right. So suppose that you want to show that subgroup N is normal. All right. See, if you can show, so if N is equal to, but in that case, it is not a subgroup in general. Right. Okay. So first thing is that N is a normal subgroup. So we know the definition of a normal subgroup. You can show that N is a disjoint union of conjugacy classes. And it's actually is a very useful fact, actually. Disjoint union of conjugacy classes. But is it any good? Arnab, can you tell us what's the definition of conjugacy class?
Wait.
Huh?
1 minute.
Okay, yeah. So you see, conjugacy class is for an element, right? Conjugacy class is something which is defined for an element. So whenever we say that G is an element, and then we write conjugacy class of G, we obviously just want to say something like this, right?
G.
All the, correct? Yeah, right. All the things that you can get by conjugating. But here one has to mention that you are, because there are two groups going around, so you have to mention, like, I am taking the conjugacy with respect to which. So here I'm taking with respect to G. Because obviously, if you take conjugacy in N only, then obviously you will remain in N, and then N can be written as a disjoint union of conjugacy classes of N. That is because any group can be written as a union of disjoint union of conjugacy classes. Right? They form an equivalence class and so on. Right? That's a standard material. Right? That is something that you know. Right? And if you don't know, then let me know. But here the point is that they are a union of conjugacy classes in G, and it's not a surprise, I suppose. But you can prove this, right? So that is one of the things. So now what happened? Now suppose I took an element sigma in N, right? And then we wanted to show that the entire oh wait, contains this, contains. So what we had is something like this, right? We had this thing, and we wanted to show that all the three cycles are there, right, in AN, correct? All the three cycles are there in AN. But then you see, what I'm saying is that, okay, then what happened? Oh. Yeah, I think there are some simpler ways to show. Anyways, let's think about this thing. Take sigma in N, okay? And our job was to show that this G sigma, or maybe our job was to show that the conjugacy class of G, the G conjugacy class of sigma, right? Means all the conjugates of sigma, right? They are also in N. Right? Or maybe I should say that our situation was slightly different. Our situation was that we had H in G, right? And in our case, what were these objects? Can you say? Sn? This was An,
Yeah.
and
Yeah.
this was, right. And this was a normal subgroup, right? Yeah. So we had 1 3 cycle sigma in N, and then we said that if you take the G conjugate of that, right? Because all the 3 cycles are G conjugates. Are so all the wait, okay, wait a minute. I think Arnav is. Arnav, are you here?
We want to show
Yes,
it is
yes, yes.
an
Yeah,
conjugate only, no?
good point. Yeah, that is what I was thinking. Right, yeah, that's why, yeah. Yes, yeah. So our question was actually not this. Yeah, but let me still write it and let's see. Okay, so let's say that this is one of the questions, but probably for the time being we'll strike this off. And what Vaishnavi is suggesting is the question. So we wanted to show that the G conjugate of sigma, and I will say this. Oh, okay. Anyways, I'm recording it. I mean, yeah, we'll yeah. Maybe in the break you can fix it. Maybe you can use some mobile data or something. Yeah. So anyways, okay. So yeah, we wanted to show that the G conjugacy class of sigma, which means in this case sigma was a 3 cycle, right? Remember, sigma a 3 cycle. We took a 3 cycle, and then we said that you consider all 3 cycles, which is basically the G conjugacy class of sigma. Just a complicated way to say it, actually. I don't think this point is, but anyways, we wanted to say that this is actually equal, not contains, but it's equal to the H conjugacy class of sigma, right? This is what we proved, right? This is what we proved. Okay, but this is not the point. The point is that we proved that all the 3 cycles, or maybe I'll write it here, we proved that all 3 cycles in AN, no, all 3 cycles are conjugate in 3 cycles are conjugate in AN. Okay, so starting from 1 3 cycle and conjugating in AN, right? Starting from 1 3 cycle and conjugating in AN, we got all 3 cycles, right? Right, yes. So you see that obviously shows that. So what does that show? That shows, yeah, that shows. So this implies that N is equal to AN. Right?
We have no we cannot say no, like uh, first we have to show it contains 3 cycle. Like
Yeah, no,
we
yes,
have
but
any
yeah, but
cycle.
no, yeah, yeah. But here we are assuming that it contains a 3 cycle. That we proved also our last day. But that is a separate issue that we also proved, right? But here the thing is that we proved that if it contains a 3 cycle, right, then that implies that it contains all the 3 cycles, right?
And
Or
all
yeah,
3 cycles will generate AN.
yes, that fact we are using, and together we are getting that AN is that this normal subgroup is AN. Okay, but what I wanted to say I could not say actually. I wanted to say that we did not just prove that N is because see, we did not use, what my point is that we did not use the group structure on N, right? If you come here or H here, right? H, this subgroup, we did not use the group structure on H. We just said that H contains conjugacy, H is closed under conjugation. And using that only we generated everything. That is something extra, right? We did not square a sigma, and because square of sigma is also in H, right? But we did not use those facts. Okay, all right. So let's take a break here and think about it. But maybe when we come back, we will do some other problems. Maybe this thing is there, but yeah. Okay, yeah. I don't know. You try to fix your connection meanwhile. And okay, let's.